Hello, welcome to MySQL QA episode number 13. This is one episode that I've been really looking forward to giving. So in this episode we'll have a look at a better approach to all MySQL regression, stress and future testing. We use random spread coverage testing and SQL Interleaving to do so. So the reason why I've been looking so much forward to this is because I have a vision that there is a better future out there for MySQL Quality Assurance. If we change the way that we do our processes, we can mend many of the bugs out there and look at each release to see how qualitative it is within a very short amount of time and with very little resources if we know what we're doing. Now, so far what has happened is that QA tests particular features and then does a number of integration testing steps, and that's a good way of doing quality assurance, but there is a much easier and better way to do quality assurance across the board for all MySQL releases, for all MySQL features, for all MySQL storage engines, all related products that will quickly, efficiently, with less resources, show us what the real quality of MySQL looks like. It's not hard for us to see at this point in our program, in this point of our quality assurance setup, how qualitative a release is. Within a few hours, myself or my colleague can work out very quickly whether we have a quality release or whether we have a poor release. That thus far hasn't been really possible, or if it has been possible, it has not been possible with the same extent and with the same coverage as we're able to do it here and now. So let's get started on pquery, and then we'll have a look into some other related items. And I hope that by the end of this episode you can see the vision and you can see how, with a number of substantial changes, because this has to change at the core, we could very quickly move from a slow, decentralized process of quality assurance to a centralized, much quicker and with much less resources process of ensuring the quality of MySQL for the future. And again, this is viable across the board. It is not just for Percona server, it's not just for Oracle MySQL, it's not just for MariaDB. Anybody out there that does anything to do with MySQL quality assurance, if they understand and grasp the concept behind this, it will be very easy, I think, to see how we can move forward to a better future for MySQL in general. Okay, so let's get started with pquery, because it's partly at the core of this, but before we go there, I need to show you a little bit more about the past and the future as to how we could do QA. So here is the MySQL server. You can see this little box here, and in the past we had features being developed by developers, and that will, I suppose, always stay the same. A developer develops a feature, a QA engineer is assigned per feature, and the QA engineer comes up with a QA test plan and the feature is tested. Now, of course, if you have a fairly new QA engineer or a less skilled QA engineer, then your QA is always going to be limited to whatever this QA engineer can put in. Even if he gets some sort of cooperation from his team, it's always going to be limited to some extent. And that's also why this QA box doesn't really fully cover the future. Even if there is a lot of skill for the engineer, they might not be able to execute everything because of machine resources, and there could be other reasons too, like for instance the feature can only be tested in a certain way, so it takes some time to set up, the release has to go out of the door, etc., etc. So there's always going to be limitations, which is to some extent fine, but it also means that these features are going to go out of the door with a limited amount of testing, mostly limited by the skill set of the engineer and by how the quality assurance is done. Also note that a feature cannot be fully tested. For instance, let's say that this feature is some sort of new locking mechanism, and this locking mechanism might need to be tested in combination with replication, in combination with partitioning, you know, all these sort of different things. So, you know, either you would have to make this QA very comprehensive, and we're talking about many months of work, or you need to find some way of merging things together. And, you know, we've not only merged things together, we've actually found a method of applying just a single QA process across the board. Okay, so that is in terms of future testing. Now, at the end of the future testing, of course, the release has to go out of the door, and some sort of integration QA is done. So all of these features are merged together in the MySQL server, and then some QA, and the QA is of course very dependent on whoever is doing the integration QA, has to happen before the release goes out of the door. Now let's say that all the features have been merged together and marketing says, okay, we have to push out this MySQL release in 1 month from now. Then integration QA might take maximum of, let's say, 1 or 2 weeks, because the developers would still require time to fix any bugs that are found. So this is always going to be some sort of conflict between QA and marketing and the developers, and you know that can of course create situations where a release might have to be postponed, or the integration QA is done only in a very limited fashion, or maybe just the QA for individual features is repeated with all the features merged. All of these are limitations, and all of these limitations are really not necessary. We can cover all of this and more by moving ahead to the future. And so what we propose for the future is the following. This looks like it might be an unachievable dream, where you know the areas that are covered by QA not only envelop the server but go beyond it. This is possible. It's not only possible, we're doing this within Percona already. So here we have the various features, and we're going to test those features by interleaving QA, and I'll show you in a minute what that looks like. Interleaving the SQL that is used for testing particular features. So I'll show you in a minute what that looks like. And we are also going to constantly test all of the server using random spread coverage quality assurance. And these two things together, when they are done, mean that a lot of the resources can be reduced. A lot of QA resources can be reduced. It's a lot easier to test. It's much more fun too, and all of these constraints in terms of features almost virtually disappear. Okay, so let's go to the next page. So this is an SQL file, an example of what we're using in our setup now. So how have we come to this SQL file? We've taken all the MTR test cases, and remember that whenever a feature is created, an MTR test case for that feature is created, and sometimes several and sometimes many, right? So we've taken all of these MTR test cases and we've compiled one large SQL file that comprises all of the SQL which is available in MTR test cases, and there's quite a bit of it. I think that you can see the line count here, 85,000, but I think there is about 500k lines in our main SQL file. So we've taken MTR test cases from Percona server, MariaDB, and upstream MySQL server, and we've merged them into 500 lines file for testing comprehensively and randomly across the board the entire server. Is very, very, very effective. You wouldn't believe how effective it is. It's extremely effective. We have literally stopped using the random query generator for lack of being able to produce issues when compared with pquery. I can give you some run details later, but if you run pquery for 1 hour, you would be able to produce between 80 and 120 core dumps per hour, and that's running with a single threaded client, single threaded MySQL. There's nothing fancy happening. We are running in memory, but that's about the only fancy thing happening. Otherwise, 80 to 120 core dumps an hour. With RKG we let it run for 24 hours, and sometimes it would find 1 or 2, sometimes it would find 10 bugs. That is running 8 threads, so 8 times MySQL D, 8 clients hammering on the MySQL Ds, but it's just very slow because of the way that it generates randomly its data, and because of the Perl backend. It has been a Swiss Army knife as to precision, but in terms of really getting an idea as to the actual quality of MySQL, that is just not there, and so we've left it behind. We don't use it anymore. Sometimes we might consider it for a little bit of SQL generation or data generation, but otherwise we've completely moved onto pquery, which is extremely more powerful. Okay, so here we have the SQL that is an example of how we've merged these test cases together, and this is very high quality SQL. So one of the problems with random query generator was that a lot of queries might fail. Within this we're getting a reasonable percentage. I think it's 1 in 4, 1 in 5 instructions or something like that will succeed, and these are executed randomly against the server. So you would say, okay, with all of these SQL combinations and with all of this randomness, how likely is it that you're going to be hitting one, remote issues? And this is an incorrect comment that is quite often made. And how likely is it that you're going to miss issues? Which is a comment not so often made, or not at all, but it's definitely a consideration. Remote issues, not at all very likely. These SQL are usually fairly standard. They're very much related to particular features. You can get an idea here of just scanning through the files. But remote issues, maybe between maybe 30%. Yeah, 30% might be remote issues, maybe 35, maybe 25, who knows. But all of the rest are going to be reasonably major issues, either in a feature or directly in the server. How likely is it that we miss issues? And that is the great part. It's very low, I think. Of course we're going to miss some issues because this SQL is not comprehensive by definition, but if there is a major issue in the code, something that's a showstopper or a blocker of some sort, it's going to be so obvious within the space of an hour, 2 hours. It's going to be all over your screen, and I can show you in a minute what it looks like, even with a run that's already been partially cleaned up. Okay, great. So that's in terms of getting your SQL ready. Now let's talk a little bit about SQL interleaving and what this is. And remember, I mentioned this in connection with feature testing. So if you have all of this random testing going on, what about if you could on each second or third line or something like that touch a particular feature that was just developed? The great thing is you will be able to touch that feature and test it comprehensively, and at the same time make sure that it integrates and works well with all the other things out there. Remember, these are the MTR test cases. These are related to bugs and features and every little thing that needs to be tested, any basic functionality. It's all going to be in those MTR test cases already. Okay, so let's move on, and I'll show you an example of what that looks like. So here we're doing an example of what a select one, if that was a future. Of course it's not a future, but if we wanted to comprehensively test select one, and I've just added a little bit of extra comment just to make sure that it's very clear how you can see how that select one is inserted everywhere. But you can take all of the SQL relevant to a future. So let's say, for instance, you wanted to make sure that the flush command works properly in combination with anything in the server, right? So what you would do is you would take flush tables, flush status, flush whatever, and you would take these statements and interleave them semi-randomly or more deterministic in the SQL. And remember that this SQL fully covers the server in pretty much every way out there, because these are the MTR test cases and they're not just the the upstream ones. There are also the Percona server ones, the extra features that were added, MariaDB ones. And so it will comprehensively cover every functionality out there in combination with whatever it is you're trying to test. In this case, select one, or here the example of flush. And this becomes very powerful for future testing. So instead of creating some new grammar in Ranchan, creating a YY grammar, and possibly even a ZZ grammar, which by definition are very limited, because you would have to set certain options, but you're limited by how random you can make things, because otherwise your runs would take too long. So instead of doing all that, here in a very easy, fun and nice way, you're going to be able to test your future very, very comprehensively, and if there's going to be an issue in that future, you're going to hit it very, very quickly. Okay, so coming back to here, so we take any SQL that we can think of which might be related to a future. It's quite a fun thing to do. You just talk with the developer, you make a list. There's a little tool, the SQL Interleaving tool, that I can show maybe a bit later, and you can run the SQL Interleaving tool to randomly insert these items, or if you just want to insert it more in a deterministic way, you could use the set command. There's a certain syntax that's available that would insert it on every end line. Okay, so this is what SQL Interleaving looks like, and you can see how powerful this would be in terms of future testing. Okay, so let's talk about random spread coverage testing. So thinking back about our QA engineer, and he could be Mr. Think-A-Lot. One of my previous bosses said to me, when I hand the future to you, the one thing that is really great is I know that it's going to be comprehensively tested. And I like that compliment, but for sure I was still gonna miss some things, right? I'm not perfect. Even if I think a lot, even if I am having a very good day, I'm going to be thinking, and that's the green items out here, about certain interactions with partitioning, with replication, with some MyISAM join in a subquery or something like that. But I'm not going to be thinking about all the possible interactions. Even if there's a list available of things that I should possibly think about, I'm still going to miss some things. I'm going to miss some interactions. And so these are the red circles, right? And so at the end of the day, I'm going to be sad, because sooner or later my future is going to hit the live production machines on the customer side, and for sure there is going to be some customer that says, hey, I run into a bug here, and I look at it and go, oh yeah, I forgot. So there's a problem. Now there's also the happy QA engineer, and that's Mr. Nuclear, and Mr. Nuclear throws an atom bomb on the future. And the problem with an atom bomb is that you're going to see every little last thing out there, and that's maybe the 30% of less important features that QA has to deal with. But they're also going to see the whole 70%, right? They're going to see pretty much everything that's out there. If you remember that flush example, for sure, if there is going to be any issue with flush, it's going to show up all over your screen, and it's going to be very clear where the issues are. Okay, so that brings me to pquery run. Maybe a poor quality screenshot, but you get the idea. pquery run is the utility that we use to run pquery against MySQL, and this goes very fast. Right here you can see it finding a bug, and it's the T1 result range bug, which is a bug that we see a fair bit. And here it's executed 2,174 trials, and it was going to run only for 15 seconds, but it found a bug within 3 seconds, right? 3 seconds of runtime. It had executed 2,174 queries. Out of those, 18.7% were successful, and bang, it hit a bug, right? So if you run this for an hour, again, you will see 80 to 120 crashes per hour, and this is single threaded. Just picture if you let this run for 24 hours on 8 threads, right, instead of just a single thread, you're going to have thousands and thousands of bugs, right? And of course a number of these are going to be duplicate, but that's what I mean with they will show up all over your screen when they're big time. When they're showstoppers, it will be very clear. Okay, so coming back to pquery, so we have also pquery prep producer, and what this does is when these trials come to a stop, at some point you say, okay, I've got maybe 2 or 3 or 500 or 1,000 core dumps. I'm going to need to analyze these, and I don't want to do that manually. Run the pquery prep producer tool. It will quickly go through all of the items, and it will grab the last query, the query that was being executed from the core dump and the one from the error log, and it will insert it to the SQL trace. So one big issue, and I'm a bit sad that it's not more clear for all of the QA engineers out there. One big issue is you might run an RKG run, and you might come up with, let's say, 10 crashes or something like that. But when you go and try and reduce them, maybe 5 or 6 are not reproducible. And the reasons are varied. Usually it's because some sort of parameter or some sort of item was not exactly matched. That's a very often seen reason. The other one is that the server crashed and RKG or whatever other tool you might be using never wrote the failing statement into your SQL trace, which of course means that if you're going to replay your SQL trace, you're not going to be getting the same crash as you should have been getting. So with pquery prep producer, you can see here at the top, it's grabbing all of the MySQL D options to get 100% match. It's grabbing the failed queries from it, extracts them using GDB from the core dump. It adds them 3 times to the SQL trace, because sometimes you need to run them more than once to trigger a bug. It also gets the crashing query from the trial log. It inserts it into the SQL trace as well, and so you might have 6 times the same query at the end of the file, which is fine. If you're running multiple threaded, it would and for instance there's 3 or 4 queries in the core dump, then you would have 9 or so or 12 statements and another 3 here, because the error log usually only contains 1 statement. That's all fine, because pquery prep producer prepares reducer scripts that can then be executed. It's as simple as just going so once you've got your run, so you do your pquery run, right, and once the pquery run is complete, you go to the results directory, you prepare the reducer scripts, and then you check the results. With pquery results, it will give you a nice overview of all the bugs it found, and that's where I say if you have any showstoppers, it will be very clear, it will be all over your screen. And the next step is, if you want to analyze an issue, you just take the reducer script for a particular trial and you start it, and this will come up with a short SQL test case, and that's it. You post the bug report, no further work. Now with reproducibility, our reproducibility is extremely high. We're near 100% reproducibility. Some let's say 90-95% of issues will easily reproduce with just starting reducer scripts like I just shown you, just because everything is matched, right? And the way that it's replayed, there's a near 100 to 100% match. So many of the issues are straight away reproducible. Some of them are highly sporadic or hard to trigger, and so they require a little bit more work. But all in all, we end up with about 100% of reproducibility across the board, which is extremely powerful. In the days of early RKG, we would have never been even able to dream that. Okay, so going one step further, pquery results, and this is from a very short run where, you know, there were 37 remaining scripts after the run. So you can see, here we go into the directory. You can see here the various trials and the various bugs that it's seen. So for instance, the T1 result range that we saw in that previous screenshot was seen 10 times across these reducers, and this was only a very short run. It was probably an hour or something like that. But if you run it for, you know, a little while longer, then, you know, you might get many more scrolling across a few lines, and so it's going to be very clear. Of course, if you look at this one straight away, you can see wow, this looks like a major bug. And of course, it's referring to T1, so maybe a table or something like that, a result range. So this looks pretty serious, right? It's very clear. There's a few issues here too. You know, that's only being produced once, but here this middle one has been produced 3 times, and so on. So it's you can see within a few hours, it's very easy to get an overview of the quality of your release or your storage engine or future or whatever it is you're testing. So very quickly about Reducer, so fully automatic, ultra fast test case reduction. We've seen you know, test cases from 30,000 lines and upwards being reduced in the space of an hour to 3 or 4 lines. We have near 100% issue reproducibility, as I said. It's compatible with sporadic issues, and recently, and this is as far as I know, a world first, we have true multi-threaded test case reduction. So it means if you're going to hit a test, if you're going to hit an issue with a pquery run, or even with some other tool, if you're going to hit an issue and it's multi-threaded, then Reducer is going to be able to reduce that for you. It's not very fast because it's working on a random sort of setup, but it's reasonable, it's doable, it's true multi-threaded test case reduction, which is a world first as far as I know. The result: 2 to 8 lines of SQL per bug, and you know, if you've been watching our work, we've been logging hundreds of bugs, most of them, if not all of them, with very high quality short SQL test cases with all of the information there. It's very easy for us to do this now. We're only with 2 guys here. My colleague Ramesh, he's a great guy. He very quickly logs bugs. I go through bugs. We're a good team, and that's just with 2 of us, right? We're going through that. So that gives you an idea as to required resources. So here you see an example of Reducer, and let me see if I can zoom in a little bit. So here you see Reducer starting and verifying using 10 threads if the issue is sporadic or not. It found that all the threads reproduced the issue, so the issue is not sporadic, and then it goes and starts simplifying them. And if you notice here in the beginning, it started with 4,000 lines, and then a little while later it will try and throw away chunk from that file, and in this case it was successful. It threw out 3,171 lines, and there was a bug. So the result would be that the test case is reduced to 800 lines, and that's in a matter of 5 minutes or so, and that includes the first startup. So within 10 or 20 minutes, this would have been reduced to a few lines of SQL. And again, that's our same bug right there that we were looking at before. Now, what can pquery do? So the pquery core is just basically a pquery binary and a framework around it. So as I said, 80 to 120 core dumps, crashes and asserts per hour. It's got a C++ core, C++11. Thanks to my colleague Alex Ibico for developing that core. It was really great when I came to him with the idea and with a vision as to how it should look. He very quickly built it, debugged it, and also thanks to my colleague Sergey, who was very good with fixing a few memory issues that we had in there. And yeah, there we go. Now we're using it all the time. Okay, 15 seconds per trial runtime with thousands of lines of SQL executed per trial. So, maybe 12,000, maybe 15,000 lines within the space of 15 seconds. Compare that with RKG. Sometimes we were running like an hour, for example. So we are nowhere near having to run anything like that. There's so many bugs out there that we've already picked up on. We're actually stabilizing now, so it will give us a little bit of an opportunity to start expanding pquery to maybe the little bit more remote cases. But for the moment, we have found pretty much every bug out there. We've done so for 5, 6, and I've also spent a bit of time on MySQL 5.7. So if MySQL 5.7 ends up being a more qualitative release, then you can be sure that it's to some extent thanks to pquery. There was a thank you from Oracle in one of their release notes, which was quite nice, and we appreciate that very much from our colleagues at Oracle, who've been doing a great job and a great stewardship of MySQL. Okay. So highly automated, as you saw there, a little bit of an introduction already, just more automation behind the scenes. We have a full framework. It's quite stable now. The basics are all there, and more than the basics. It's quite highly automated. You can go from doing a QA run to logging 10-15 bugs within the space of a day, if not less. Okay, so we have 3 binaries available, and those binaries now have included client libraries, so you don't need any dependencies anymore. We've got them for MySQL Server, we've got them for Percona Server, and we've got them for MariaDB. They're already in the tree. You can go and get them and play around with them. Very easy to use, very easy to get going. We also have support for pxc. However, we used Docker for testing, and Docker has changed their fix setup to Docker Compose, I think it is, and so that has changed a little bit, and we need to do a little bit more work there. So pxc is somewhere in the loop. So definitely compatible with third-party tools, storage engines, and whatever else you want to test with it. So in the first 2 months of its life, we logged over 200 bugs, most of them with very high quality test cases with Oracle, Percona, and Tokitech. As you know, Tokitech was acquired by Percona, so we're one company now, and now we get to fix those bugs too. So we're up to 300, and this is an old number. We must be quite a bit over that now. Most of them with 2 to 8 line SQL test cases. The community is showing interest. Some big names there that have said, hey, look, we're going to have a look at using pquery for our testing, and as I mentioned, the stewardship of Oracle, they've been great with fixing the upstream bugs. So I have found that the bugs that I've logged with upstream with 5.7 or 5.6, they mostly have received core issue analysis. What do I mean with core issue analysis? That actually somebody goes and looks at them and figures out what the problem is. If we have a car and we're driving around with a broken light, and we keep driving around with a broken light, sooner or later our engine is going to blow up. Well, the guys at Oracle have been great. They've been actually looking into the engine and figuring out what's wrong. Not only that, they've fixed a really good number of bugs, and so 2 thumbs up for the guys, for the developing team there. Really cool. Okay, 13 part QA series, and you know that this is the 13th episode in there. So that's the link to it. You can go and have a look, or just search for QA Series Roel or something like that, my first name, and for sure you're going to find them on the Percona blog or on the YouTube channel of Percona, where it's got a separate series channel in there. Okay, so that's in terms of the Percona pquery framework. Now let's go and dig a little bit deeper and see what it looks like. Okay, here we got our cell session, and I just happened to notice that it's 13 today, and it's 1300 hours. I didn't do this on purpose. This actually just ended up happening. I thought it was a nice little tidbit for getting into it. So I've got a previously executed QA run here. So basically I would have executed pquery run from Percona QA, and it would have just created a subdirectory here, and you can see how we've been working on various things. And it would have created all these trial directories, and I've already partially cleaned up this run just to make it a little bit nicer visually. I used this in one of the previous episodes. These reducer scripts were then subsequently created with pquery prep reducer, and that would have created the scripts in here. So if I now run pquery results, then we get a nice overview. So this ran for X amount of time, and like I said, I cleaned it up so that this particular bug was 3 or 4 or 5 lines of trials. It's not necessary to show you, but it gives a good idea as to how it's very clear to get a good quality idea of your feature that you're testing, either with SQL Interleaving or just across the board with a general run. In my opinion, general runs are quite sufficient. Now think about this. If a developer develops a new feature for MySQL, then he will include by default 1 or more MTR test cases. So we have a tool that is called MTR to SQL, and it grabs all of these test cases, not just these, but all of the ones from the whole server, and it puts it into a new flat file where we have all of the test cases from Percona server upstream and MariaDB in one file, and then our testing is executed using this particular file. So if you think about that, where we are using the SQL, we already have the SQL from this particular feature included here. Nonetheless, you could go one step further. If it's quite an important feature, you want to go and have a look at the SQL and say, hey, there's something missing, and add this to the SQL file, or do some interleaving and go and test it. Where else can interleaving be very interesting? Well, let's say that you have some sort of customer, and this customer uses these particular statements very often, and they run into some sort of crash. Well, why not take those statements, interleave them within your general file, and maybe standardize them a bit, like always refer to table T1 or something like that, and then do a run against this. And why would you not see the same crash happening as this customer is doing? Because you're using their statements as well as most of the SQL that has been ever developed for MTR, and so these are very high quality SQL test cases that are being merged into that. Of course, that process is not perfect, and there's a little bit of filtering, but a lot of the goodness comes across from all of these MTR test cases, and in time we could maybe improve that a bit, but it's only slightly improving. Most of the good quality would come across. I can show you a little bit more about that if you like later. So coming back here to the results, we can see that we've had quite a number of issues. We did 720 trials, and there's 144 remaining reducer scripts. And so you can see, okay, this issue here, yeah, sure, it was hit one time, but it's probably not going to be, something that's a very major showstopper or blocker. Here are some issues that are showing all over the place now. In this case, they relate to character sets. So again, it's easy to get an ID even just by the little description here, although if you go and have a look into the error logs, notice how it's very easy. You can just go log error, and you can have a look in the error log, figure out, okay, this is some sort of char set issue, and so it's not going to be very important to raise, but there might be some other ones here. Okay, so something related to tables and bitmaps, or something related to flush, right? But it's only happened one time. Okay, something related to index. Oh, it's only happened one time. So you can get an idea as to what your quality is like quite quickly. And for instance, this would seem like an interesting candidate to have a look, a little bit more of a look at. What other one? Okay, so here we got something to an interval value, maybe something related to timer, but it's only 2 times. So relatively easy to get an ID. And if there's a major issue, it's going to be all over the screen, because there's going to be hundreds if not thousands of trials that have failed, and so it's going to be seen 40, 50, 200 times. So that was a very quick and high-level introduction to pquery and the pquery framework, as well as random coverage testing and SQL interleaving. So just for clarity, random coverage testing, it means that you're going to cover randomly your entire server, and yes, this is possible, as you would have seen and understood by now. And we're going to test particular features within the server with SQL interleaving, which is going to test not just that particular feature, but also a large part of the server. And you can see how all this would lead to a lot less resources required for quality assurance. Okay, great. I hope that you caught on to some of my enthusiasm for the future of MySQL testing. This goes across the board. You can do regression testing with this, you can do stress testing with this, and you can do feature testing with this. I hope you give it a try, and it's a slightly sad moment because it's the end of the QA series, but I hope you enjoyed it, and otherwise, God bless. Bye. My name is Roel van der Paar, and I work for Percona.